Setup here on the lathe, and I'm going to show and talk about some of what I'm doing as I do it. So I'm going to go into jog mode, and I'm going to move the turret to where when I spin it, I have no doubt that it's just not going to collide with anything else. And so I need to start loading tools. I know off the top of my head, I believe I know the whole tool list memorized, which is handy. Otherwise I would have a setup sheet like this that would mention, tool numbers and what the tools are. But I standardize things as much as possible, and I think I know what I'm doing here. So if I had jog mode and I go down to tool position 5, I actually want to change tool 2, but because the tool is inverted, I know from memory that it's easier to access that tool in this position. So for me, tool block 2 does my V-style, VCMT, VCGT, V-style finishing tools for both the main side and the sub side. So this is tool 2 offset 2, tool 2 offset 14, and magnetic strip is awesome improvement. So these are my high positive aluminum sort of cutting inserts, and I use these for aluminum, titanium, copper, bronze, brass, plastics, but I don't use them for steels and stainless. So anyway, the way that I took it off, with this being the last used edge, I'm gonna point that toward me and I'm gonna put it in this little holder. This is obviously a mess, but that's the idea, is that this thing, that way I can put it back on the same way it was and I don't lose track of it. And I use one or two of these, either one or the other insert on just about every job. And put the screw through the hole. Grab the air blow gun. Probably a little bit of anti-seize would be a good idea. I've never had a tool, never had a screw strip out on, milling insert tooling or lathe insert tooling, but probably someday it'll happen. So wouldn't be a bad idea to get some anti-seize on there. So anyway, that's that tool, and it's got the same general shape and nose radius, so I don't usually touch it off for XY again. You could, but generally I just measure the diameters and the sizes of my parts to make sure I'm in spec, and I assume that the previous dimension was probably still acceptable. So let's just jog the turret a little bit away, and then I'm gonna go down to turret position 2, and I'm gonna do the same thing with this one. We're doing a stainless steel part next, and I need these turning inserts on the main and the sub spindle side. These aluminum inserts just would get destroyed. Yeah, it's such a mess. You want to film your shop and then you realize how much of a slob you are. I mean, I already knew, but it's tough not to just constantly apologize for the mess. And so these are ISCAR tool holders, 1-inch stick tools. They're coolant fed. I don't think this would hold up to high pressure coolant, but it works for the standard pressure. And then these little nozzles point the coolant right at the edge, which is a cool idea. I don't love the implementation. There are other brands and other configurations of coolant fed tool holders that probably work a little bit better. Sometimes chips get caught up under these things. Also, the nozzle can retract, and sometimes it just gets stuck retracted, which maybe is fine, but anyway, I've seen some other ones that are maybe nicer, and these were not cheap either. Each one of these was, I don't know, 200 bucks or something, but anyway, so that's tool block number 2. I know that tool block number 6 has a drill that I'm gonna need to load. Now, with the way that I do my turret, I don't have to screw around too much, so I have 3 of these tool blocks that have quad position 1-inch bores. So I use a 4mm hex key. These are M8 set screws, and I modified these blocks. I drilled through so that now the coolant flows through the bores themselves, whereas previously they only flowed through these little 15mm balls that I have all blocked off basically. I don't think that that's a very good way to do coolant. So here you can see I have a 1-inch shank ER25, and that's coolant through. These are super cheap and pretty effective. Coolant sealing collet, through spindle coolant drill. And so anyway, I need to switch now to a 3.3mm drill, which I think is this one. And let me verify. I don't know where my calipers are, so I'm using a mic. Yeah, 3.3, thought so. And this is actually a fancier version of that same kind of tool holder, but you know, having the drill already set up and having the coolant already routed makes setting up tools really quick compared to if those things I just said were not true. So jog Z, jog X. And so for me, this turret position is always tool 6, offset 6. I even laser etched it in there, a little hard to see. But anyway, now I have to, there's a certain song and dance for this. I have to hit jog mode, and then I have to hit, in this case, Z negative to move the tool that way. Once I press this button, it starts very slowly feeding until that light goes red, and it reverses, I don't know, 1.5 millimeters or something like that. And then I want to jog off, and now I can hit my quick setter button, which raises the tool eye, and reference return, talking and doing things at the same time, a little bit distracting. So okay, I have my turning tools. I know tool 9 gets used, but I believe that's already loaded, so that's this spot drill. However, this one won't work because there'll be a collision if I leave that in position. So I'm gonna pull that one out. This is pretty damn quick and pretty effective for the amount of money I have into it. Like those came with the machine, and then each one of these tool holders is like 25 bucks on Amazon. Collet is 12 bucks. Carbide drill is, you know, 60 or whatever it costs. They're sometimes kind of expensive, but they're awesome, so it's worth paying for. But as compared to like a Capto tool block or something, it's incredibly affordable. And that drill is out. So I made a bunch of these early on when I got this machine, and the shape of this, there's a reason. So it's 1-inch bore plug, and that just, you know, keeps chips out and it keeps the coolant in so that the pressure of the coolant can flow where you want it to. That's all I need to do. It's loaded. And then this shape here, I ran these right after I ran another part that had a similar looking end, but that's actually useful because when you go to remove it, you just put the wrench through there and you can pull it out. Whereas if you didn't have that, it might be a little hard to grip. So works good for me. It's not as low profile as it could be, but it seems to be low profile enough. And while I'm in here, I think I'm also gonna just shove this back in. I had to extend it some for the last job just to get it to clear that other drill. And these machines are kind of a clearance nightmare, you know, in every direction. Anyway, that's there. So now I need to retouch this one off for Z. So I do the same thing again, jog, quick setter, that comes down. And feed it in. So jog Z, and so it's highlighted on 9 for X, and so we'll see this Z value change from 76 to, let's see here, there it went, and now it's 64. And so, you know, that's a good thing to pay attention to. Does the number look reasonable? Did it change? Feed off, quick setter up, reference return, and then I know I need to do tool 12. And I believe that's already set, which it is. So that's just a really small kind of grooving turning tool. I use that to pick out an inside corner where I need a smaller radius than the radius that I get from my actual finished turning insert that we loaded first. Now there's a bunch of other tools on the turret that we don't particularly need, but that's the ones we need loaded. I want to check on this parting insert, which I don't really change that out job to job. This is a 24 position turret, and it's actually a little bit annoying because on this, if you're at like position 12 and you want to go to position 1, if you press the plus button, then it'll take you to position 13, which I don't really want. So I got to press the minus button all the way down until I get to 1. So that's the one. I don't really use the 24 position. The half positions are, I've owned this machine almost 3 years and I have yet to think of a use for that, but maybe someday. Anyway, so I want to get a better look at this edge. I was running a titanium job last, and I don't know how well that shows up on camera. That's chewed up a little bit. I believe that's a little bit chewed up, so I'll change that out. That's a ISCAR TAG style insert. Alright. So you use this tool with the 2 pins, and you push it in and you pull it out. So, right? Yeah, no, that's chewed up. I don't know if you're gonna be able to see that, but I would say that's chewed up. So if we go, nope. There we go. Blown carbide, and I think each one of these is like $17 or something. They work pretty good, but let's see here. Goes there. Make sure that's clean. So I just get it kind of lined up in there. So this is an integral parting block from ISCAR. It's pretty sweet. Now the business end of it has seen some damage. If you can see that, kind of had to grind it some and rotate it. It's got four places to hold this, but I've been using the same one for, like, you know, the whole time I've had this machine, so almost 3 years. And then this here is like, I think a 3D printed and sintered metal coolant nozzle thing, and it directs the coolant from below and from above onto the parting edge. And the whole thing is just a brick shit house. And importantly, this will flush cut against the sub spindle. It doesn't flush cut against the main spindle, which can be annoying, but it's more important that it be able to flush cut against the sub spindle. And so, let's see, jog X, feet away, reference return. There we go. So I think my turret's set up now. I'm gonna double check that. But yeah, we got all those. So now let me show you the coolant on. All right, so we loaded this this drill here on the sub spindle side. There's an ID groover. If I turn on the coolant though, yeah, that's pretty good. And in fact, I might even take that. I don't know if you can see it very well, but yeah, this is doing what it's supposed to do. It's pushing the coolant through the tip of this small diameter drill. I'm gonna actually remove this one from the turret, just because the coolant flow here is reducing the pressure that this drill sees, and that would maybe be fine, except that this drill is already a little bit too small. So the small diameter through spindle coolant drills, ideally you would give them a lot of coolant pressure in order to get the coolant to flow through those small diameter passageways all the way to the tip, and to properly back flush the coolant. And so since I don't really have enough coolant pressure in the first place, I don't really want to lose any coolant pressure and flow to this tool. And so I'll be removing it and putting in one of these plugs, and then maybe get slightly better performance on that drill, slightly better reliability. So that tool comes out. And here's one of those plugs. So again, that cross hole is helpful. So you can kind of work it around. I see, it was kind of rubbing because this was already half preloaded. Anyway, that should do it. And I don't really need to change the offset when I remove it. I just know that when I load a new tool, I have to, you know, check it for certainly for Z-axis and maybe for X-axis also. So when I switch from that boring, you know, tool, which does have an X-axis offset, to like a drill, I need to reset to center line. I have a pretty slick way of doing that. I'll show you in another video sometime. And now if I turn the coolant on again, very little coolant is lost through the rest of the orifices and holes and whatever in that tool block. Most of the coolant just goes through the tip of the drill. So I would say that's probably gonna work better. And if we go to tool 9. Let's check that one out. That works pretty good. So now if the way a lot of people run a lathe turret block is they have, you know, the coolant ports, you know, like these little coolant balls are actually what deliver the coolant, or they have little copper lines that angle out and squirt at the tip. And if you can just feed coolant through the tool itself, it makes setting up a lot faster. And so that's what I prefer to do, and it works really well for me. So this is a little boring tool. You know, this is a spot drill. They're drills. I even have, let's see here. Down here, this is a, you know, this tool here is solid carbide with a 3/8 of an inch shank or something. I just have that clamped in a collet, and when I load it, I just twist it until it's, you know, lined up with the x-axis of the machine, and I touch it off. And then that one there is going to get, if you can see that, you know, pretty good coolant flow. And in that case, I think I even have this coolant ball is open. It wouldn't necessarily need to be, but yeah, I just really like using, especially these tools that make for a pretty quick changeover when you're setting up a job. And so yeah, that's pretty much it. You know, I could talk all day, but that's setting up the turret.